Theorem. Intersection of two subgroups of a group G is also a subgroup of G. Proof. Let H1 and H2 be two subgroups of a group G. Then H1 intersection H2 is non-empty as identity element E belongs to H1 and E belongs to H2, where E is the identity element of the group G. We have to show that H1 intersection H2 is a subgroup of G. For this, we have to show that if A belongs to H1 intersection H2, B belongs to H1 intersection H2, then A into B inverse belongs to H1 intersection H2. Diagram: G is the group, H1 and H2 are two subgroups of G, and this portion, shaded portion, is H1 intersection H2. Now A belongs to H1 intersection H2, implies that A belongs to H1 and A belongs to H2. B belongs to H1 intersection H2 implies that B belongs to H1 and B belongs to H2. But H1 and H2 both are subgroups of G. Therefore, A belongs to H1, B belongs to H1 implies that A into B inverse belongs to H1, A belongs to H2, B belongs to H2 implies that A into B inverse belongs to H2. So, A into B inverse belongs to H1 and A into B inverse belongs to H2 both, implies that A into B inverse belongs to H1 intersection H2. Thus, we have shown that A belongs to H1 intersection H2, B belongs to H1 intersection H2 implies that A into B inverse belongs to H1 intersection H2. Hence, H1 intersection H2 is a subgroup of G. So, intersection of two subgroups of a group is also a subgroup of the group. Note: the unions of two subgroups is not necessarily a subgroup. For example, let G be the additive group of integers, that is G is equal to Z is equal to 0 plus minus 1 plus minus 2 is a group under usual addition. Then H1 is equal to 0 plus minus 2 plus minus 4 plus minus 6 dot dot dot, that is H1 is multiple of 2 and H2 is equal to 0 plus minus 3 plus minus 6 plus minus 9 dot dot, that is H2 is equal to thrice Z. Here H1 and H2 both are subgroups of G. Now H1 union H2 is minus infinity to dot 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 minus 6 minus 4 minus 3 minus 2 0 2 3 4 6 9 8 9 up to infinity. In this case we see that H1 union H2 is not closed with respect to addition, as 2 belongs to H1 union H2. Here 2 belongs to H1 union H2. Also 3 belongs to H1 union H2. 3 is also there in H1 union H2. But their summation 2 plus 3, which is equal to 5, does not belong to H1. 2 plus 3 is equal to 5 does not belong to H1 union H2, since 5 is absent in H1 union H2. Similarly, we can see that 3 belongs to H1 union H2, 4 belongs to H1 union H2, but their summation 3 plus 4 is equal to 7 does not belong to H1 union H2. Therefore, H1 union H2 is not a subgroup of G. However, H1 intersection H2 is equal to 0 plus minus 6 plus minus 12 plus minus 18, that is H1 intersection H2 is equal to 6Z or multiple of 6 is a subgroup of G. If we take another example, H3 is equal to 0 plus minus 4 plus minus 8 plus minus 12 of G, then H1 union H3 is equal to H1 and H1 is a subgroup of G. We can prove that the union of two subgroups is a subgroup if and only if one is contained in the other. Theorem: the union of two subgroups is a subgroup if and only if one is contained in the other. Proof: let H1 and H2 be two subgroups of a group G. Suppose that H1 is contained in H2 or H2 is contained in H1. Then H1 union H2 is equal to H2 or H1. But H1, H2 are two subgroups of G. Therefore, H1 union H2 is also a subgroup of G. Conversely, suppose that H1 union H2 is a subgroup. We have to show that either H1 is contained in H2 or H2 is contained in H1. Assume that H1 is not a subset of H2 and H2 is also not a subset of H1. Now H1 is not a subset of H2 implies that there exists A belongs to H1 and A does not belong to H2. Suppose this is case 1, and H2 is not a subset of H1 implies that there exists B belongs to H2 and B does not belong to H1. This is case 2. From 1 and 2, we have A belongs to H1 union H2 and B belongs to H1 union H2. Since H1 union H2 is a subgroup, therefore A into B is equal to C, say, is also an element of H1 union H2. But A into B is equal to C belongs to H1 union H2, implies that A into B is equal to C belongs to H1 or A into B is equal to C belongs to H2. Suppose that AB is equal to C belongs to H1, then B is equal to A inverse C belongs to H1, as H1 is a subgroup of G and A belongs to H1. This implies that A inverse belongs to H1. From equation 2, we have B does not belong to H1, which is a contradiction. Again, suppose AB is equal to C belongs to H2, then A is equal to C into B inverse belongs to H2, as H2 is a subgroup and B belongs to H2 implies that B inverse belongs to H2. But from 1 we have A does not belong to H2. Thus, we get a contradiction. Hence, either H1 is contained in H2 or H2 is contained in H1. Thus, the union of two subgroups is a subgroup if and only if one is contained in the other.